two parallel plates separated by a distance of 10 cm. A distance of 10 cm. Come on, look at the distance. 10 cm are charged to a voltage of 40 volts. We're expected to estimate the amount of electric field intensity on them, between them, okay? So what do we do? If we have this as a parallel plate, don't mind my diagram, and another one, a parallel plate. Okay, they're parallel. These two plates are parallel to each other. The distance between them, that's the most important thing. The distance between them is 10 cm. Alright? They are charged. There is a potential supply, or rather a voltage across them, charging them to a voltage of 40 volts. So we are expected to charge them to 40 volts. 40 volts each. And the question is, how much electric field intensity is accumulated within them? So that's what we're going to do. Estimate the electric field intensity between them. Very simple. If you still remember what we did last time in my previous video, what we learned last time in my previous video, you would have known by now that electric field intensity E is stated as V, the potential, over what? D, alright? Where E represents the field intensity in question and V, the potential difference. In other words, the voltage given to them. And then in the distance, if we have E as unknown, alright, okay, then V is known as 40 volts. Very simple. And then what happens next? The distance D is known as 10 cm, which is equivalent to 0.1 meters. Good. So with this data, we can find the electric field intensity. So what do? We come here and state it clearly. E is given as V all over D, and we substitute E is equals to 40 all over 0.1. 0.1. Let's see how we're going to resolve this. Let's see how we're going to resolve this in a very simple way and arrive at a particular answer. This is interesting, isn't it? Okay, let's see. We can do that quickly. It means that our E is giving us 40 all over 0.1. I have just repeated what I have here. Okay? Because I want to solve it in a very simple way for us to understand. Okay? Now what do? Is E is equal to 40 all over 1 times, of course this should be 10. Maybe this will be a bit confusing. Let's do it this way. 40 all over 1 over 10. And this simply means 40 all over 1 times 10 all over 1. Can you see? I think it makes sense now. Okay? So with this, we know that E is given as 40 times 10. 40 times 10 all over 1. And this will give 40 times 10 is 400. Therefore, E is equal to 400. Something is remaining, right? The units. We are not done yet. I just want to call your attention, please. Remember to subscribe. Give thumbs up. Put on the bell button for constant notification. Don't forget, before I let you go, share with your friends. Come on, share with your students and networks. The weather is changing, it's about to rain, it's already drizzling. So I'm trying to make this happen before I let you go. What happens here, because E is given as V all over D, V is volts, D is measured in M, right? We have what? Look at it there, volts per meter. Good. And we have our wave. Very simple. So we have this, the electric field intensity between the two plates. Look at it. Between the two plates, a certain amount of charge, maybe Q1 and the Q2, doesn't really matter, is this. And then we are done. We are done here. I am signing out, believing or hoping you have learned something new. Thank you for your patience and for watching up to this moment. Come on.